cosine B, guys help me out here, it's minus this time, cosine A, sine B, and step back, make sure I have this formula written out correctly. Miriam, do I have it written out correctly? Is that the formula you'll be using? For sine A minus B?
Yes.
Okay, and then replace, and she's going to be doing this, look at this. Caroline, wow. Did you ever help us out? Cosine, 3 pi 4, sine 5 to 6. Jonathan, with what Miriam gave you, it's got to give you the same answer. Here's my answer. It looks like it may not, I'm getting scared. Let's see if it does. Guys, this would be a sine of 3 pi over 4. Oh my goodness, that is on the unit circle. I think it's radical 2 over 2. You guys can check this unit circle. Cosine of pi over 6, we all know is radical 3 over 2. Whoa, 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 whoa. It is. Cosine of 3 pi over 4. That's where it gets tricky. What's the cosine of 3 pi over 4, the x coordinate at 3 pi over 4? I think it's negative radical 2 over 2. See if I'm right. And sine of pi over 6 is 1/2. All that from the unit circle. With Miriam's help. I bet if I clean this up, Miriam, I see right now you're going to get radical 6 over 4 here for sure. Look at this. That's going to turn into a plus. And then those two multiply together is radical 2 over 4. Same answer. Same answer. Thank you, Caroline, Miriam. And I'm sure there's some other possibilities maybe out there that you could use, and use one of the formulas there. Great. Okay, guys, go to part B, I guess. Now, I'm looking at, maybe this is part C for us. Power volume. Is this the one you came up to me at the break asking about? Is it part C? Where it says cosine, and I have some brackets around this thing?
Yeah.
That's the one? Get ready. Oh, get ready. This would be an extra credit problem. This would be a nice extra credit on your exam. Get ready. And I better get ready. It's going to look like this. Erase this. And guys, this one says cosine. Put it right here. Brackets. Inside there is inverse tan. Oh, Professor, I thought we were finished with inverses. No, here it comes again. Subtract inverse cosine 5/13. They want to. Philip, sitting right in front here. This one scares me. Scares me. It scares the instructor, I can imagine. Mr. Park probably scares you too. Arena, I think this one may scare you. Can anyone tell me a start? Anyone shocked when we now see inverses first. Inverses can get scary. You say, oh no, Professor, inverses with this new set of formulas? Yes. Can anyone tell me first of those formulas I have listed, which one might be applied here? Just the way that it's presented, the way it looks, which of those, I think it's 4 formulas, which one might you use? You got it? That's the formula that fits. So we'll jot down first that formula. So to get the answer, cosine A, cosine B, plus sine A, sine B. Absolutely. Ben, was that you who gave me that?
Yeah.
Yeah. Now, Ben, perfect. Perfect. That's what you're going to use. Now, guys, look at this. Cosine A needs a replacement. And number. All they gave me for A is something about tan. But I have no idea what cosine A is. I know what tan is. Cosine B? Well, we may have lucked out here because that may be cosine B right there. Involved. Lucked out there. Sine A, back to the A? No, they just give me tan. Sine B, they give me cosine. So I need to come up with replacements, and we'll approach this two different ways, guys. I know I've got some students in class who could probably do this right now. But here we go. Does anyone, let me do a little translation for you as we talk. Does anyone think they know a way to, they gave me inverse tan, inverse cosine. Does anyone think they know a way to start this mess? It's a mess. Now, if I had a calculator, you know what I would do? If I had Mr. Park do it for me, he would just press that inverse tan key, put in 4/3, and the screen will show him what A is. I know. And then this one, he would just press that inverse cosine key, put in that 5/13, and the screen will show him the size of B. And then he subtracts the two, and then takes the cosine of that. And he's got the answer, and he's gone. But we're not using calculators. Now, I'm hearing students give me some responses already. Guys, first we give you something, and then we'll go from there. I know just from maybe before the break, inverse tan 4/3 says this. Tan, translation, A is equal to 4/3. That's what it says. And A must be located, by restriction for an inverse, here. Between a negative pi over 2 and a positive pi over 2. That's inverse tan translated. Now, we do, trying to find a good marker level. This will work for me. Now I need a good translation for, that's A out of the way. Now I need to do a good translation for this one. Inverse cosine 5/13 means cosine B is equal to 5/13, comma, and the inverse cosine had a restriction. The angle must fall between 0 and pi. And step back, guys, and see if you agree with, are those the translations for the inverses that we did before the break? All that inverse work, is that what those inverses mean for me? Okay, let's go back. Now, trying to think about Ray, what she did for us here. I know tan A. I'm looking for, if I want to use the formula that Ben gave me, I know tan A, Professor, you need cosine A. I don't have it. And also, Professor, you need sine A. All you know right now is tan A. Now, can someone come up with maybe an identity that might lead me to either sine or cosine that I put in to my formula? All I know right now is tan. Adrian?
Tan is sine over cosine.
Whoa. I know tan is sine over cosine, but here's the issue. I love that. Hang on. Adrian, every time I teach this course, as a student, I'd probably say the same thing. Oh, come on, Professor, sine over cosine, and they gave you tan, so sine, here it is, sine must be 4, and cosine must be 3. I would think like that. Can someone tell me, though, it looks like so obvious. Sine should be 4, cosine should be 3, but sine over cosine, that's tan. Can someone tell me what's wrong with that argument? I wish I could do that, but what's wrong with that argument?
Cosine is 5 over 13.
Do it again.
Cosine is 5 over 13.
Who's up next?
It's that, if you look at y over x,
Y over X.
then 3 and 5, right? Because it would be cosine equals 5 over 13, so x would have to be 5, and then you could, x also equals 3.
Oh, I see what you're doing. You're in your mind, you're sort of visualizing a triangle, which I'm gonna do shortly. But something just more obvious. And I would overlook it as a student, being honest. Because Adrian, I would say the same thing you did. Why not let sine be 4 and cosine be 3? Adrian, tell me.
Because the radius isn't 1 in that case.
Thank you. Thank you. On the sine graph, we got a graph part of the quiz, I'll tell you more about that. Sine, this parent sine graph. Does anyone remember what the max was? How much did sine go up to?
1.
1. Not 4. Not 4. There's no angle out there where sine is 4. Mr. Park, try inverse sine 4 and see if the calculator shows an angle whose sine is 4. It does not exist. The max for sine is 1. How about the max for cosine? Look at the graph. It goes up to what? 1 again. And this one, it says, I think we're thinking about what, 3? There is no angle out there, period, whose cosine will give you a 3. 1's the max for cosine. So I can't use that sine over cosine procedure. Caroline?
Because they're both inverses, they share quadrant 1.
Well, there,
Would you
it's in
look-
quadrant 1, for
Would
sure.
you look for the radians in quadrant 1?
I will be in quadrant 1. But I need more information. And I'm what you want, we'll finally get to quadrant 1, but I'm gonna try to do it through identities first. Ray, that I'm read by you. Okay. Identities. And then we'll do, Caroline, we'll do what you guys are suggesting, the triangles. Does anyone have an idea, guys? We got tan A, I need cosine A or sine A. Is there an identity out there, not sine over cosine? We tried that business. Is there another one that maybe somehow would relate and finally lead me to where I want to go? What about?
Sine 2 plus cosine 2.
Let me get it.
Squared, sine squared plus cosine squared. And we said like 4a plus 3a, like 16a2 plus 9a2. I don't know if I'm.
But you're trying to think, I see what you're doing. You're trying to think about sine squared plus cosine squared?
Yeah.
I was thinking about something else. I might be able to follow you. I'm thinking about something else, maybe, yes.
We can have the y equal to 4 and the x equal to 3, then add the y squared plus the x squared.
I got you. This is what Jonathan's saying. Guys, I think you're trying to get me to the triangles first. I think in your mind, you're thinking about a visual. Please, Professor, visualize this for me. Show me what's going on here. Okay, let's show it visually first. And then we'll come back and use identities. Guys, first, you do it. Jonathan, you were thinking about this. Let me do it. And if I do it, here we go. Let's place Caroline. You said, Professor, the way it looks, the one in green, angle A, it's definitely in quadrant 1. Let's do this. So we put A. Here we go, guys. A good lesson tonight. Let's put it in quadrant 1. Let's mark it in green, so I know where it is. She tells me, Professor, it's here. Now, Adrian, I'm coming back to you. Now, if you would like to drop a perpendicular the x-axis always, and form a small right triangle. We're gonna have this. Which is what finally leads you into chapter 7. But right now, small right triangle. All I know right now is the tan of A is in the green, the tan of A is 4/3. Now you can do this on a triangle. You say, wait, professor, it's this side over this side. Isn't it? That's tan, y over x. Yeah. But that gives me the hypotenuse, which really is the radius of c squared is equal to a squared plus b squared. I think it's a 5. And since we're accustomed to a unit circle, I need to convert that real quickly into a unit circle by dividing everything by 5. That's what Johnson had in mind. Now, I know something about angle A. Since I did it there visually, I'm gonna leave it right there. Caroline, let's do the one in black here. I guess over here. Angle B, I think angle B is also in quadrant 1, the way it looks. So let's go over, place, angle B, quadrant 1. Have this. Again, you drop a perpendicular. The right triangle to work with. Now this is to represent angle B. At this point, what do we know? We know cosine is 5/13. If I'm thinking about cosine, Miriam, I'm thinking about cosine as x. If I want to do this on the unit circle. Just x. It looks a little strange, but could I say this is 5/13? Would that be cosine?
Yes.
That's when I'm assuming this is a unit circle. Now I can find the other side. And the other side would be c squared is equal to a squared plus b squared. Pythagorean theorem, I'm going to do it quickly. 1's equal to 5/13 squared plus the side I'm looking for, we'll call it y squared. This is 25 over 169 plus y squared. Guys, if I move that over, common denominator 169, I think I end up with 144, just save myself a little time. Equals y squared, take a square root, thank goodness it's perfect, 12/13. Whew. It's going to be positive, talking about the length. So it's 12/13 on this side. Now I have angle B illustrated. Angle A has been illustrated. I should now be able to fill in the values there in the blue that I need. I hope so. Or in the red. I'm using the formula to get the answer. Guys, let's go back and start putting numbers into the red there, and that should calculate into the answer here. What's my time here? Here we go. Cosine A, here's the A sketch, is cosine merely 3/5. In fact, I think we knew that earlier, but 3/5. I look at my sketch. Cosine B, B's over here. The cosine there, or the x is what? 5/13. Don't mess up here. Plus, now sine A, oh, it's back to the A sketch. Sine should be 4/5, that's the y. Sine B, back to the B sketch, sine there, the y is 12/13. Did I put my numbers in correctly? I don't have Park to check this for me. Did I put the numbers in correctly? Visually? Okay, here goes. 15 over 65 plus 48. I'm getting scared of this. 65. Oh my goodness. Is that 63? Over 65. Are you what? class that are looking now, they're saying, oh, whoa, what? Ramsey, did you just do? Are you kidding? Mr. Park, I need your help. Here we go. We're going to first verify it, then we'll discuss it. Would you use your inverse tan key and put in 4/3 and see what the calculator shows the angle really is? Put it in degrees.
Okay. 53.
53, roughly 53. Hang on. Now I'm supposed to subtract from that. Now would you press your inverse cosine key and put in 5/13?
That's 67.
67?
Yeah.
You didn't make a mistake, did you? You sure it's 67? Okay, I'll take it. We're supposed to now subtract these two. A subtract B, that's what it says subtract. Now 53 subtract 67, guys, I knew that myself, what is that, negative 14? Now, find cosine of a negative 14. What's cosine on the outside? Find cosine negative 14.
I'm bad at this computer. I'll use my calculator.
So you're saying it should equal 63?
We'll get the approximation, and I'll ask him to approximate 63 over 65. It's gotta be. If this guy's doing it working correctly.
Okay, 0.97. 0.97.
0.97.
Yeah.
Now wait a minute, now 0.97 was when you did, hang on, when you did what? Oh, this is negative 14. You took the cosine of a negative 14. You did take cosine negative 14 degrees. And you got 0.97. Now, would you please see what we have 63. Take 63 divided by 65.
0.97.
We have the correct answer. Oh. Adrian, if I had met you guys at the door the first day I met you and presented you this problem, I said, welcome to summer 2025, math 2. I think some of us would. Whoops, I don't think so, Professor. Guys, look at this mess. Now, we did it without a calculator, non-calculator. We got the exact answer. 63 over 65. Wow. Ray, here goes. I'm gonna use another method. I'm gonna use another method, not touch a triangle. Corbett, you're trying to help me out. Let's do it through identities. Now first, can someone start out, because I've got two angles going on, A and B. All I know at this point is tan A is 4/3. And cosine B is 5/13. Now if someone can give me one of the identities out there, I don't care which one you find first, A or B, which one you deal with, A or B. Can anyone give me one of the identities that might help me with either one of them? And let's redo the problem.
Tan squared plus 1 is equal to secant squared.
Whoa, 1 plus tan squared is equal to
Secant squared.
secant squared, that's she's doing the agreement, I think. Okay, 1 plus tan squared is equal to secant squared. I agree 100%. They give me 10 to be 4/3. Put that in. Wait till you see what's gonna happen. That's 1 plus 16 over 9. Equal to secant squared. Add those two up with the common denominator of 9, guys. I think it's 25 over 9. Thank goodness, that's gonna be perfect. Take the square root. Caroline told us earlier it's in quadrant 1, so it's gonna be positive. And it's 5/3 for secant. Beautiful. Now, what else can you tell me? Because I'm using this formula. If I know secant is 5/3, what should cosine be? Aren't they reciprocals? If I do the cosine right now, please tell me, just flip this over from the reciprocal. Just flip the 5/3 over. Is that what we got earlier? Now tell me, we may not do this completely, thank you so much. Now can you tell me another identity that may help me find something else? So we need to get this one's out of the way. Could I find sine?
Yes.
Sine of A, I guess, the green one? If I use what, sine squared plus cosine squared? Stack these up. Here's another identity. I know you guys are saying, Professor, really? And this is sine squared. Make sure you guys can see this. Sine squared plus 3/5 squared equals 1. And it's going to be sine squared. We'll stop here shortly, guys. Is equal to 1 subtract, that's 9 over 25. So move that over, subtract it 1, subtract 9 over 25. I think it's 16 over 25. Do a square root. Sine of the green is 4/5. And I think we put 4/5 in right there. So this could be done using identities. I didn't finish it completely up because of the time here. Barbara, is that the one you were thinking about?
Yeah.
What a workout. Now guys, this would be an extra credit. I'm not gonna place it on an exam and you guys take an hour working on it. No, this would be like an extra credit on the side to see if you can work it out. Okay? Now I'm looking at my time here. I have limited time. What's going on tomorrow? Quiz. The only thing you need to worry about is how to sketch the graph up. I'm gonna be very, very nice tomorrow. I know we have 6 trig functions, and I have gone through the graph of all 6, I think. You said, Professor, when I walk in tomorrow for my last quiz, are you gonna ask me to graph something with a cosecant? Are you gonna ask me to graph something with a secant? A tangent? Cotangent, I think I left it up to you guys to find. A sine or a cosine? Michael, of those choices, which one do you think would be nice to have your last quiz pertaining to? Thank you, sine or cosine. And I did. So all you need to worry about tomorrow is the graph, and it's going to involve sine or cosine, which are the easiest. Tan and secant and cosecant have asymptotes. So I'm not going to do asymptotes on the quiz. Final exam, or no, exam 5 coming up, exam 4 coming up what? Friday? And maybe a different story. Okay, but tomorrow, Nima, something with sine or cosine. So guys, what I'd like to do in the last few minutes I have here, and thank you so much, Miriam. We're right at chapter 7. We're not quite there yet, but we're going to get there tomorrow, today. Okay, guys, on the side here, I want you to practice with one. I'm going to let you practice with it. Get some input from you, and I'm going to drop one in. Practice with. So many papers here. here it is. Okay, sketch one complete cycle, let's say of this. That, just one problem quiz. Guys, take just a few minutes, and you and I will work it out together, so you can see the complete solution.
It's all on like graphs and.
Yeah, just grab it, and then I'll ask you for the domain, range, and things like that.
We're still gonna have the transformations on the quiz, or can we just do the final?
I have in my directions, you may use transformations or the boundary. It's up to you. Okay, guys, we're out of time, I hate to stop you. Now, if you want to use transformations, go for it, but if you do, you better bring colored pencils. Because you're going to show me each transformation. Now, I'm going to do, in my limited time here, I'm going to do it through bounding. You go directly to the graph, okay? Guys, by bounding, that means bound this. And my bounds are from 0 to 2 pi, just like the parent graph when we did earlier. Okay, so let's go from 0 to pi bound this. Now solve for x, and we'll move that pi before over, one way of many ways. Do not let me mess up, I'm adding pi before, guys. If I add pi before down here, I think we're going to end up with, help me out, 9 pi before, I think. Then divide by 2, or take 1/2, and we'll end up with pi over 8, x, take 1/2, 9 pi over 8. Did anyone in the class do it by bounding? Did you end up with those bounds? Beautiful. Now it says go directly to the grid. Let's get this done fairly quickly now. Place those. And we'll start at pi over 8. Leave some space. Let's go down to 9 pi over 8. And I need some intervening points, of course, and we found those by spacing. Got to find a number to space by. So what we did, we took the period, and we're going to find the period. The period should be 9 pi over 8, the ending of the cycle. Subtract the beginning, and that's going to be 8 pi over 8. We're going to just call it pi. Divide this by 4. Reminder. Guys, you want to be spacing by pi over 4. Now, since I see pi over 8's already on there, it may help you to make it look like this. Let me change this to 2 pi over 8. So everything will be in terms of 8, maybe a little easier. And start adding 2 pi over 8. So this becomes 3 pi over 8, 5 pi over 8, 7 pi over 8, yes, 9 pi over 8. I love the bounding, it just takes you directly to the graph. Now this is done. Don't have to worry about this any longer. All I need to worry about is you got a vertical shift down 6. Show that. That's here. Extend this down. Show my axis is down there now. Gotta be careful. Get this work out for me. You guys want to put it like this so you can see it. There's my axis. There at -6. Now, all I need to worry about is, this says it's being reflected or it's upside down and stretched by 4. Let's get that stretched by 4 out of the way first. I'm at -6, so if I go up 4, stretched by 4, 1, 2, 3, 4, am I at -2? If I go down, stretched by 4, I think we're down here at what, -10? Let's get those out of the way because it will play a part. Now, the cosine graph, parent cosine graph, I know what it looks like, but this one's flipped over. So guys, I think the parent graph started at 1. I think it went up to 1 at the beginning. At the beginning here at pi over 8, mine should be where? -10, it's upside down. And then 3 pi over 8 should be on the axis. Be careful, I'm talking about the axis right there, not up there. 5 pi over 8. Where should it be now? -2, so I'm gonna squeeze that in, right there. 7 pi over 8, back on the axis. It's like our 0. 9 pi over 8, back down at what, -10? And if I connect these and make it, these go over. there's one complete cycle of the graph. Okay. How many students see it like this? Thank you. You guys who are doing it by transformations, it won't take a little bit more time. It will eventually get you there. I know. Okay, now domain. Now when I asked for the domain, there was a domain on all the cycles, the entire function. So that's easily answered. That's this. The range though, no matter what cycle you look at, the up and down goes from a -10 up to what? -2. There's my range. Period, we've already said what the period was. It was pi. Amplitude, there is an amplitude here, be careful. It always is the coefficient stuck out front. It's 4. Domain, range, period, amplitude. Can you guys think of anything I'm leaving out? Now, before we close down, I will ask you, Miriam, to do this. I'll ask you, we're not gonna do it tonight, but you'll be doing it on the quiz. Here's your function. I'm gonna ask you algebraically to find, for an example, f of 7 pi over 8. By directly replacing x by 7 pi over 8 back here. Crunch this out. And you should get, if the graph is correct, -6 for an answer. So we'll ask you, I'll find the value for you and ask you to do f of that, crunch it out, and then go back to your graph and see if it agrees. Make sense, guys? One problem? Yes? No? Are we okay?
Good.
Okay, now I'll be here at 2 o'clock. Geez, I think we're wiped out. We're done. We're done. So much. Okay, guys, I'll see you. Oh, we got questions, yes.
Is the number that you're gonna be choosing one of the numbers that is gonna be like in the middle?
Oh, I have to. Yeah, I'm gonna be choosing one, yeah, good question. If I ask you to find f of something and it's not on your graph, it's like, whoop, I messed up. Ah, good question. Okay, guys. Caroline.